to develop a line of heavy-duty transmissions that establishes new standards for reliability, durability, and quality. With customer needs as our primary focus, work is proceeding on the crudely conceived idea of an instrument that would not only supply inverse reactive current for use in unilateral phase detractors, but would also be capable of automatically synchronizing cardinal gram meters. Such an instrument is the turbo-encabulator. Now, basically, the only new principle involved is that instead of power being generated by the relative motion of conductors and fluxes, it's produced by the modial interaction of magneto-reluctance and capacitive duractance. The original machine had a base plate, prefamulated amulite, surmounted by a malleable logarithmic casing in such a way that the two spurving bearings were in a direct line with the panometric fam. The latter consisted simply of 6 hydrocoptic Marsal vanes so fitted to the ambifacient lunar wane shaft that side fumbling was effectively prevented. The main winding was of the normal Lotus-O delta type, placed in panendermic semi-boloid slots of the stator, every 7th conductor being connected by a non-reversible tremie pipe to the differential girdle spring on the up end of the gram meters. The turbo-encabulator has now reached a high level of development, and it's being successfully used in the operation of Nofer-Trunnions. Moreover, whenever a fluorescent score motion is required, it may also be employed in conjunction with a drawn reciprocation dingle arm to reduce sinusoidal depleneration. Thank you.
Thanks, Bud. Now that we know how the turbo-encabulator works, let's take a closer look at its diagnosis and service. For the purposes of obscurity, we have removed the casing to expose the heart of the turbo-encabulator, the magneto-reluctance modial interactor. Since little or nothing is known about the principles involved in magneto-reluctance, diagnosing faults can be a problem. Connect the DRB2 to the aft end of the MOXIE interrupter using special adapter WU-PD2, making sure the osmolality of the phase detractors is not extrapolated. Begin the test by selecting model year, transmission systems, and turbo-encabulator run test. If there are any system faults, they will be displayed in secret code on the DRB2 display. It's a simple head code. Anyone can catch it. The most common fault is sigmoid rumbling below the belt line, which the customer will refer to as a burping or even a hiccuping noise. To service this fault, refer to the turbo-encabulator diagnostic procedures manual and songbook and perform test TE10. Using the Geiger scale on the DRB2, measure the wrench-in output of the capacitive reactance flux muster. If it is above 10 RGs, replace the unit. If it is below 10 RGs, you will be directed to perform a series of tests that will effectively raise the billable hours for the service department, but will perform no other useful function. All other faults should be treated as if they do not exist, and the customer should be told that the burping or hiccuping is normal and is caused by too much gas in the fuel system. Well, that's about it for this month's Master Tech. Be sure to watch next month when we'll cover ashtray and cigarette lighter operation, diagnosis, and repair. See you then.